Shall we start?
Yes, sir.
Okay, fine. In earlier lecture, we have started the plot plan and we have discussed about the basic data. In basic data, we will see the engineering sections, electrical non-facilities, meteorological data, process data, and data on utilities, and statutory requirements and expansion philosophy. Now we'll discuss the steps to be considered in continuation with development of plot plan. Now some steps we are discuss under the developing a plot plan. Now see steps involved in plot plan. That is a raw water storage shall be placed closer to water source. Fire and raw tanks shall be located together, and fire station shall be away from the hazardous area and nearer to the main gates. Now, effluent treatment plant shall be located away from the process and utility area on the downwind directions. The workshops contractor said storage yard shall be at centralized location service by peripheral roads. Two gates are prepared, one for the material entry with weighbridge and other one for mm, man entries. Now next is administrative block. Laboratories shall be located closer to the main entry gates, and process unit can be separated within financing the providing additional gates. Consider recommendation from the statutory authorities for the inter-unit distance, and residential colony shall be located away from the plant more closer to the city limits. Now next point is points to consider while developing the explosive tank form, which requires CCOE approvals, that is Chief Control of Explosive. See here, we are discussed yesterday, there is a plane table survey map. So that kind of plane survey table map to draw in industry and based in the basic design data, so that we can consider their respective locations in plane table surveys. In plane table surveys map through this, we can show the documents, the extent of the plot with the overall area, identifying all the existing constraints such as transmission lines, structures, ponds, place of worship, if any. The survey covers 20 to 30 meters beyond the extent of the specified plot to show the nearby roads, drains, and broad feature the neighboring plots. This will also show the graphical north directions, the location of power and water. Next is contour survey maps. In contour survey maps, it shows the level of the plot with respect to the mean sea levels. These levels are taken at 10 meters grids so that the topography of the plot is well represented. This will establish the coordinates, normally north, south, and east, west, or it could be XY as well. The contour map will also show the benchmarks indicating the mean sea levels, that is we called MSL, to establish the level of the plots. Now see the points to be considered developing explosive tanks, which required CCOE approvals, that is Chief Controller of Explosives. So, in this section, layout of liquid storage. So, layout of liquid storage we see based on classification of petroleum products. In classification of petroleum products, we see the different kind of classes: class A, class B, and class C. In class A, liquids which have flash point less than 23 degrees centigrade. And in class B, we have flash point 23 centigrade and above, but below 65 centigrades. And class C, liquid which have flash point 65 centigrade and above and below 93 centigrades. Do you know what is a flash point? Yes? Anyone? See, flash point is the lowest temperature at which liquid can use of vapor to form an ignitable mixture in air near the surface of the liquid. The lower the flash point, the easier is to ignite and the materials. The fire point is usually few degrees above and flash points. Then what is the flash point of a liquid? Flash point is the minimum temperature at which a liquid forms a vapor above its surface in sufficient concentration that can be ignited. Flammable liquids have a flash point of less than 100 Fahrenheit. Liquid with lower flash points ignite easier. So these are the criteria for regarding the flash points. Now, what we can exclude petroleums, liquid which have flash point above 93 centigrades. So, flash point above 93 centigrades liquid, we can exclude the classification of petroleum products. Now, next is regulatory quantity above which license is necessary. So, for regulatory quantity, petroleum class A, that is 30 liters. In case of motor, convenience or stationary engines, capacity of fuel tanks comes under class A. And petroleum class B, here 25,000 liters, provided it is a constraint in respectable, not exceeding 1,000 liter capacities. And next class, that is petroleum class C. So here we have to consider 45,000 liters, much quantity above which license is necessary. And next one is a layout consideration for explosive tank forms. Petroleum storage tank shall be located in dike enclosure with roads in all around the enclosures. And dike enclosure should be able to contain the complete contents of the largest tank in the tank form in case of an emergency. Enclosure capacity shall be calculated after deducting the volume of the tanks other than the largest tanks to the height of enclosure. A free board of 200 millimeters shall be considered in fixing the height of the dike. In case of excluded petroleum, the capacity of the dike enclosure could be based on spill containment and not containment on the tank ruptures. The height of tank enclosure dike shall be at least 1 meter and shall not be more than 2 meters above average ground level site. However, for excluded petroleum, there is excluded petroleum class C, where it can be 600 millimeters. Class A and or Class B petroleums can be stored in the same dike enclosure when Class C is stored together. All safety stipulation applicable to Class A and Class B shall apply. Excluded petroleum shall not be stored in the same dike. Tank shall be arranged in two rows so that each tank is approachable from the surround road. The tank height shall not exceed 1.5 times the diameter of tank or 20 meter, whichever is less. The minimum distance between the tank cell and inside of the dike wall shall not be less than one half the height of the tank. The height is considered from bottom to the top curve angles. It is better that the corner of the bound should be rounded and not at right angles, as it is different extinguish fire a 90-degree angle corner because the air compression effects. There should be minimum of two access points on opposite sides of the bound to allow safe access or escape in all wind directions. Distance to be observed around the facilities in installation shall be given the different petroleum rules, and we have to consider different tabular forms so that based on that we need to consider their explosive tank forms. So to consider the distance around the facilities in an installation as per the relevant regulations, the tabular forms as per the regulatory standards. So here minimum safety distance for flammable, corrosive and toxic gases. Water capacity of vessels in liters. And second column minimum distance from building or group of buildings, line of adjoining properties. And third column that is minimum distance between pressure vessels. So here see the water capacity of vessels in liter not above 2000 liters. Then we have to maintain the minimum distance from building or group of buildings or line of adjoining property, that is 5 meters. And minimum distance between pressure vessels is 1 meter. So this way we have to maintain the minimum distance for building or group of buildings or line of adjoining properties and minimum distance between the pressure vessels for water capacity of vessel that is above 2000 but not above 10,000. And third, here we have to maintain the distance that is 10 meters. And minimum distance between the pressure vessel is 1 meter. And in third case, water capacity vessel is above 10,000 but not above 20,000 liters. Here we have to maintain the minimum distance from building or group of buildings or lines of the adjoining property is 15 meters, and minimum distance between pressure vessel that is 1.5 meters. In fourth case, that is above 20,000 but not above 40,000 liters. In this case, we have to maintain the distance that is 20 meters and minimum distance between pressure vessel that is 2 meters. And in last case, that is above 40,000 liters. Here we have to maintain the minimum distance between the 30 meters and minimum distance between the pressure vessel is 2 meters. So that kind of minimum safety distance for the flammable, corrosive and non-toxic gases and toxic gases. We have to maintain the distance. So based on that, we can consider their minimum clearances in the process unit when we have to consider layout of gas storage. Storage vessels are not allowed below ground levels. They are to be installed above ground levels. Vessels shall be located in open. Vessels are not to be installed above one another. If vessels in the installations are more than one, the longitudinal axes of the vessel should be parallel to each other's. The top surface of the vessels are required to be made in one plane. Vessels installed with their dish ends facing each other shall have screen walls in between them. The distance to be observed between two vessels in one installation and distance from building or group of buildings or line of adjoining properties per regulatory authorities. We have to maintain the distance between vessels in one installation and distance from the building or group of buildings. The area where vessels, pumping equipments, loading and unloading facilities, and direct fired vaporize are provided shall be enclosed by an industrial type fence at least 2 meter high along with the perimeter of the safety zones, and minimum distance to be observed around the installation shall be as per the guidelines regulatory authorities which are we have seen in this particular in tabular forms, notwithstanding anything contained in sub rules above. The storage of LPG, that is a liquid petroleum gas, can be placed underground or covered by earth in such a manner and subject to such condition as may be specified by the notification by the central governments. And above ground vessels for storage of corrosive, flammable, or toxic gas in liquefied state shall be provided with enclosure wall around the ground. The minimum distance between the vessel and enclosure wall shall be the diameter of the vessels or 5 meter which is a less. Ground shall be graded to form a slope away from pumps, compressors or equipments. The height of the enclosure shall be 30 centimeters on the upper side and gradually increasing to 60 meters on the lower side, at the end of which a shallow sump for collection the spilled liquid, if any, shall be provided. So, for this minimum safety and clearance to be considered in process unit, and we have to follow these norms which were laid down by the statutory authorities. Now here we are finished the plot of plan. Now we will see the next topic, that is equipment and piping layouts. Equipment and piping layout arrangements cannot be segregated to have different approaches. Since the requirement of equipment and piping layout design often overlap, equipment is arranged in the process flow sequence in plan and elevation, and piping is laid to effect the process flow. It is very appropriate to say that the equipment and piping layout design is an art, not a science. There is not a single formula available for the design of equipment and piping layout. The equipment layout design can be as a rational as the mathematics of fluid flow, but with the language of projective geometries. Mathematics is abstract, geometry is visual. All engineering courses have mathematics. Few have the subject of projective geometries, but none has layout design. However, systematic methods and procedures can be developed from engineering principles, specifications, practical engineering know-how, and just simple common sense. All these should be coupled with the capacity to visualize the arrangement of equipments and piping three-dimensionally. The design must take constructability, economics, safety, quality, and operation into account. All these should be achieved within the shortest schedule and will demonstrate the technical capacity along with creative talent and common sense approach to problem solving. Although the tool to achieve these goals have changed from pencil and paper to computer graphics, the responsibility of the piping engineers remain the same. During the planning stages, the piping engineer could meet the simple ideas that can effect substantially cost savings. Let us take a practical example to it. In a chemical process industry, a waste heat boiler had to be installed at the exhaust of a diesel engine to recover the waste heat. The job was awarded to a consulting organization on a turnkey basis. The design activities look the different sequences. See the sequences. The process group work out the requirement parameters. Did the process design of the heat exchanger and issue process a data sheet that is called as PDS to the fabricated equipment group. We call the FEG, fabricated equipment group, who did the mechanical design and issue the drawing to the piping groups. Piping group located the heat exchanger and designed the inlet piping and also did the flexibility analysis of the same piping as it is subjected to high temperatures. To save the equipment, an anchor was placed near the inlet nozzle with an expansion bellows. The data of the anchor loading was passed on the structural group who designed a brace structure to take care of this. The total costs become prohibitive. At this point, a suggestion was made to turn the waste heat boiler upside down and this eliminating the heavy structures and thus eliminating the heavy structure. The final design turned out to be simple and cost effective and occupied less space. So here you can see these two sketches. Here we can consider as design waste heat boiler and then to save the minimum cost design. So based on these criteria, so we can form the process group and piping groups and then structural groups. So based on that, we can consider the waste heat boiler upside down and thus eliminating the heavy structure. The final design structure turned out to be simple and cost effective and occupied less space. This is very important criteria while considering the different groups. Then different steps are involved in plant designs. Now we'll see all steps. Now first step involved in plant design, that is conceptual layout design. Second, equipment layout design. And third one is piping layout design. Mechanical design and development of the plant has different steps. First is conceptual layout design, equipment layout design, and third one is piping layout designs. We'll see one by one all design layouts. First one is a conceptual design layouts, and second one is equipment layout designs and piping layout designs. These are not sharply divided areas, though equipment arrangement can be made along with the piping layouts. It is normally dealt with separately in large plants. The plant layout can be the biggest cost saver in chemical plant design. Next to the process and equipment design, money wasted or save can be substantially between alternate layouts. In addition to capital costs, the plant layout shall also influence the operating and maintenance costs. There are long term benefits that affect profitability. Incorrectly established plant layouts can have serious impact on safety and operabilities. If the layout does not have enough room, the plant will be overcrowded, unsafe, and difficult to operate and maintain. On the other hand, and over a generous layout result in unnecessary high capital investment. Now, we'll discuss the first step in plant design, that is conceptual layout. In conceptual layout, it is a part of the basic engineering package. The design of it is a highly innovative activity. In this, only the essential process design requirements are established. Horizontal and vertical relationship of equipment is spelled out. The space allocation is there for all the basic plant requirements, such as laboratories, offices, storage, etc. Access for operation, maintenance, and construction is provided for. Control rooms, motor control center rooms is also planned. The basic size of the building or structure is worked out. The resultant drawing is the conceptual layout. Normally, small scales of the order 1 is to 200 or 1 is to 100 are used to represent the same along with simplified presentation techniques. Plant along with necessary cross sections complete these drawings. Changes in the process, operating philosophy, or requirement equipment type and size can be aimed in substantial changes in the conceptual arrangements. Hence, it is imperative that being a basic document proper throughout should be given while generating the conceptual layouts. So we can illustrate the conceptual drawing. So here we can illustrate the conceptual drawings with the help of plan ground floors or plan ground measuring floors and then the sections. So that kind of illustration for conceptual layouts can illustrate with the help of these sketches. Now next is equipment layout designs. In equipment layout design, so we'll see different steps are involved. First one is a PFD, that is a process flow diagrams, piping and instrumentation diagrams, we call the P&Ds, project design datas, and next one is the equipment size and buildings. Under equipment sizes and building, we'll see the inline layouts, similar equipments grouping, and functional equipment grouping. Now, next is guidelines and new approach. In guidelines and new approach, we'll see the area calculation and volume calculation. Now, next step in equipment design, equipment layout design is the equipment layout and unit plot a plant drawing. Now, third step in plant design is piping layout designs. Now we'll see the equipment layout designs. In equipment layout design, so called it is an extension of the conceptual layout in more detailed manners. In the same way, as the P and D diagrams, that is, piping and instrumentation diagrams, are the basic documents of chemical engineering design. Equipment layout is the basic document of mechanical engineering design. This is a composite mechanical engineering design, coordinating the design information to produce construction drawings. Generally, all equipments and facilities that need floor space, access, removal space, cleaning areas, storage space, and handling facilities are outlines. Good layout design minimize the cost of operation and maintenance. Access is the most important feature to be considered. Constructability is another factor, which have equal importance. Equipment layout of large outdoor plant is sometimes referred as plot plan. This document is the basis of the development of construction drawing by all disciplines. Information required for the preparation of the equipment layout is more extensive than those required for the concept layout design. The essential design data required for the preparation of an equipment layout is process flow diagram and piping instrument diagrams, project design data, equipment sizes and buildings, guidelines and new approach, and equipment layout or unit plan drawings. Now, first, the requirement, the preparation of equipment layout is a process of flow diagrams we call PFD, or piping and instrument diagrams, that is we call P and D. PFD and PID, the most important document referred to by a layout engineers. They show how each of the equipment is interconnected. P&D means piping and instrument diagrams indicates the information such as solid handlings, gravity feed, line slopes, loop size, venting and draining requirements, special piping materials which govern the equipment location to a great extent. Utility flow diagram shows the individual service lines and utility headers. Now next is project design data. In project design data includes the geographic locations, proximity to roads and railways, topography and local codes and regulations. It also enlists the weather conditions such as rainfall records, seasonal temperature difference, wind directions, outlet point for drain. This data affects the design of storm water drain and requirement of enclosures. Further, the wind direction influences the location of cooling towers, furnace, and inserters stacks. Grade elevation is usually referred to a datum such as 100 meter and is referred to an absolute level in the plot plan. This is fixed at the ground floor of one of the major process plants, and it is absolutely essential to establish a consistent elevation relationship between various facilities. The plants and the major equipments are located with the reference coordinates that are established in the plot plan. So, with the help of project design data, we have to consider different parameters when we are considering their appropriate distance. The project design data considered the soil characteristics, decide the foundation depth and the required area to be occupied. This affects the equipment spacing to care of foundation interference and layout of drains. Now next parameter in plant design, that is equipment sizes and buildings. Equipment includes fabricated equipments such as vessels, heat exchangers, reactors, tanks, and proprietary equipment such as pumps, compressors, furnace, filters. The layout and piping arrangement characteristics of these shall be dealt with subsequently. However, certain general principles are followed in locating the same. The equipment is a group to have the optimum location for minimum pipe run, and process flow sequence is followed to establish the functional performance the same. In equipment size and buildings, we'll see the inline layout. Inline layout, this parameter, see the exchangers are placed next to towers and thermosimpan reboilers. Might be you have studied the different kind of boilers in refrigerant air conditioning or fluid mechanics. So here we can place exchangers are placed to next to the towers and thermosimpan reboilers which have large diameter pipelines are attached to the boiler and tower as well. Towers are arranged with individual platforms for several in a line. Generally, surge drums, storage vessels, coolers, heaters are placed between distillation column in the process flow sequence. Next is similar equipment groupings. In similar equipment grouping, operating or maintenance convenience and safety consideration can detect the grouping of equipments. Group exchanger and inline up channels ends make possible the use of common gantry crane moving on rail in front of for bundled removals. Columns can be lined up to have a common platform for manholes and wall operations. Reactors or agitated kettles can be grouped to have a common operating levels and lifting beam for the agitators. Utility equipment is normally housed together for operating convenience. Process compressor under one roof are a frequent requirement. Pumps in a row can facilitate a better rack layouts, cable arrangement, and maintenance accessibility. Next is a functional equipment groupings. In functional equipment grouping, cost of alloy steel or stainless steel piping initiates a compact arrangement of equipments. Bolting condensers on top of the distillation columns as a part of the same, stacking heat exchanger one above the other are some examples. Reactors are arranged in a row which needed crane or trolley for removing equipment internals and for material handling equipments. Containing acid or toxic material is a group and located within a pub and curb area which will have the facility to drain out the effluent treatment plant or for neutralizing it. The building size in an outdoor plant includes the different kind of rooms, control rooms, laboratories, and space required for personal facilities. These are worked out in coordination with electrical instrumentation and civil structural groups. Now, next is guidelines a new approach. In guidelines a new approach, we'll see the area calculation and volume calculation. Now, first we'll see the guidelines a new approach. Layout guidelines for major equipments are based on minimum distance required between various types of equipments to meet the insurance regulations. They are designed to help prevent major catastrophes, especially when highly inflammable chemicals are involved. These guidelines, while useful, often include ambiguous entries such as provide spacing based on access for operation and maintenance as required and not applicable. Hence, these guidelines only could still result in crowded plants. And the solution is to study each piece of equipment to determine the needs of operation and maintenance. However, is an extremely time consuming activity and is quite possible to be overlooked or not accounted for certain specific need. As a result, the plant layout become a subjective topic left to an experienced piping engineers. Quantitative method is evolved by earlier piping engineers for evaluating the quality of a given layout in the early part of the design. Two complementary calculations meet this criteria. The results are then compared to those of plants in similar service. Both good and bad layouts used in conjunction with established practice. This new approach can improve engineers' ability to evaluate the equipment layouts. Now, we'll discuss remaining area calculation, volume calculation, and equipment layout and unit plan drawings, and third steps, that is piping layout design. Up till now, if you have any doubts, any questions, you can ask your doubts and questions. Yes, anyone? Ravi, Suraj, Praful, Anushka, Harshal.
No, sir, no doubts.
Okay, very good. So, anyone? Any questions?
No, sir.
No, sir.
Okay, fine. Then we'll close this session and we'll continue with guidelines and new approach with area calculation, volume calculation, and remaining subtopics in our equipment and plant layout designs. Okay, I think
Yes, sir.
we'll close
Thank,
this
thank you,
session
sir.
here. Okay, fine. Arnav.